welcome to this final tutorial of Chapter 2, Data Preprocessing. I look forward to being well prepared with our data to start making our machine learning models. It's going to be very fun. We just have to hold on for one more tutorial and then we're good to go. Okay, so today we are going to talk about the feature scaling, which is very important in machine learning. I'm going to explain why right now. So I'm going to open our dataset. And here it is. Okay, so let's explain what is feature scaling and why we need to do it. So as you can see, we have these two columns, age and salary, that contains numerical numbers. Let's just focus on the age and the salary. You notice that the variables are not the same scale because the age are going from 27 to 50 and the salaries are going from 40k to 90k. So because this age variable and the salary variable don't have the same scale, this will cause some issues in your machine learning model. And why is that? It's because your machine learning models and a lot of machine learning models are based on what is called the Euclidean distance. If you remember that back from high school, the Euclidean distance between two data points is the square root of the sum of the square coordinates. Well, actually here it's the same. We have two variables, age and salary. So you can picture age as the x coordinate and the salary as the y coordinates. And in the machine learning model's equations, some Euclidean distances between observation points, for example this one and this one, are computed based on these two coordinates. And actually, since the salary has a much wider range of values because it's going from 0 to 100k, the Euclidean distance will be dominated by the salary. Because, for example, if we take two observations, for example, this one, the 9 one, and the third one. Well, the Euclidean distance will compute the difference between this salary and this salary. So let's compute it. That's about. So this minus this, as you can see, this is 31,000. If you put that in square, you get it C up, that gives this. And now let's take for the same two observations, the ages. So let's compute 48 minus 27. Okay, that's the difference. And now let's take the square of 21 is 442. So you can see very clearly how the square difference dominates the square difference. And that's because these two variables are not on the same scale. So you know, in the machine learning model equations, it will be like this doesn't exist because it will be dominated by this. So that's why we absolutely need to put variables in the same scale. That is what we are going to transform these two variables. And they are going to have values in the same range. For example, they are going to have values from -1 to +1 here. And same here, -1 to +1, so that we don't get this sort of problem with huge number here dominating a smaller number here, so that eventually the smaller number doesn't exist. There are several ways of scaling your data. A very common one is the standardization, which means that for each observation and each feature you withdraw the mean value of all the values of the feature and you divide it by the standard deviation. So that's the first type of feature scaling, and another type is normalizations, which means that you subtract your observation feature x by the minimum value of all feature values, and you divide it by the difference between the maximum of your feature values and the minimum of your feature values. Don't worry if you're not very comfortable with the mathematics here, but what you need to understand is that we are putting our variables in the same range, in the same scale, so that no variable is dominated by the other. Okay, so let's do it right now. Anyway, you're going to see how the variables are going to be transformed, and you are going to see how they go from having large and very different values to small and the same values. So let's do it. Let's start with Python as usual. Here we are in Python. The feature scaling section is ready with the common feature scaling, so let's start right now. Okay, As usual, we are going to import a library to do this, and we know with this library we already saw it. It's the preprocessing library, and from this library we are going to import the standard scalar class. So let's do it. We are going to import from sklearn.preprocessing and import standard scalar. Alright, so that's the class we need to import. Then as usual, we are going to create a new object of this class, and we are going to call scx. Because you will see later that we might need to create another object that will scale the dependent variable vector. But so far we will only need to scale the X matrix of features. So scx equal with standard scalar. And now very simply, we will directly fit and transform our training set and our test set. So let's do this. We are going to transform xtrain. So xtrain equal, we will recompute xtrain because we want it to be scaled. And so to do this, we're taking our object xtrain equal with scx. And then we're calling the method fit transform. So that's very important to understand that when you're applying your object standard scalar object to your training set, you have to fit the object of the training set and then transform it. And you're going to see that it's not going to be the same thing for the test sets because we will only transform the test set. But for the training set, we need to fit it and then transform the training set. So okay, here we will just need to add parenthesis xtrain. And that's it. And now the same for the test set. So we are going to copy this line and pass here. But we need to change xtrain to xtest. And now, as I just said for the test set, that we don't need to fit with the scx object to the test set because it's already fitted to the training set. So here I will remove fit and we are good to go. Okay, now there are two questions that we can ask to ourselves. The first one is really important and you will find a lot of this question on Google. This question is, do we need to fit and transform the dummy variables? As you can see, the dummy variables takes values either 0 or 1. So do we need to scale that because it seems to be already scaled, right? So if you ask this question to Google, you will find several answers, you will find several things for that. Some will say that no, you don't need to scale these dummy variables. Some say that yes, you need to do this because you want some accuracy in your predictions. And if you're interested in my opinion, I would say that depends on the context. It depends on how much you want to keep the interpretation in your models. Because if we scale this, it will be good because everything will be on the same scale and we will be happy with that and it will be good for our predictions. But who will lose the interpretation of knowing which observations belong to which country, etc. So as you want, it won't break your model if you don't scale the dummy variables, because there will be actually on the same scale as the feature scales variable here, which we take values between -1 and 1. We will see. But since here is our final tutorial and we won't have any interpretation to make, we will scale those dummy variables. Alright, so that's how feature scale. Now let's execute this line. And here we go. Okay, so now let's check our xtrain and xtest. Okay, here's xtrain. As you can see, all the variables now belong to the same range, to the same scale. As you can see, all the variables seems to be between -1 and +1. So that's perfect. That will largely improve your machine learning model. And besides, I forgot to mention that even if sometimes machine learning models are not based on the Euclidean distance, we will still need to do feature scaling because the algorithm will converge much faster. That will be the case for decision tree, because decision tree are not based on the Euclidean distance. But you will see that we will need to do the feature scaling because if we don't do it, they will run for a very long time. Okay, and let's have a quick look at X-test. It's also feature scaled, and you have to understand that the feature scaling here in X-test is the same with X-train because we used the same object SCX and was fitted to X-train. That's why it's very important to fit the object to X-train first so that X-train and X-test are scaled on the same basis. Okay, now I promise you another question. The other question was, do we need to apply feature scaling to y as dependent variable vector? So, to y-train and y-test, here as you can see the dependent variable is a categorical variable because it's taking only two values such as 0 and 1. And now the question is, do we need to apply feature scaling on this one? Well, the answer is no this time. We don't need to apply feature scaling to this one. However, we don't need to do it because this is a classification problem with category called dependent variable. But you will see that for regression, when the dependent variable will take a huge range of values, we will need to apply feature scaling to the dependent variable y as well. But let's not worry about that for now. You will see how we will do it in the regression section, and actually you will see that it's very simple. We will just be doing the same thing as we did for X-train and X-test. Okay, so that's good for Python. Congratulations! Now you master of feature scaling in Python. Perfect. Now our data is ready to offer a good precision and good accuracy and a fast work of machine learning models. And by that, I mean that the machine learning models will converge rapidly. Okay, so that's it for feature scaling. Now you know how to apply feature scaling in Python. Congratulations! We did all the required steps to preprocessing data as chapter 2. Feature scaling was the last one because the next chapter we will build our model in several regression models. So we are done with the data preprocessing. You did the most difficult part and now it's time to have fun. It's time to start making the models and I can't wait to start them with you on the next chapters such as chapter 3. So thank you for doing this tutorial. I look forward to seeing you on the next one. Enjoy machine learning and have a good day. See ya.